Voyager 1, launched in 1977, was conceived as an emissary from Earth, a spacecraft carrying scientific instruments and a golden record containing music, languages, and the aspirations of humanity. Over the decades, it has traveled farther than any other man-made object, leaving the Sun's influence behind and entering interstellar space, where the solar wind dies down and the environment is a thin mist of gas and dust from ancient stars. For a long time, it was a silent guardian, sending invaluable information about the farthest corners of the solar system and the interstellar environment back to Earth. But after 42 years of travel, something unprecedented happened. The probe began transmitting data about a constant, coherent signal, an anomaly that did not correspond to any known natural phenomenon. The initial detection was made by the Voyager's plasma wave system and cosmic ray detectors. Although these instruments were developed in the era of floppy disks, they are still capable of detecting minor changes in the environment. Engineers noticed fluctuations in the plasma data, pulses that were unnaturally regular, unlike the fluctuations of the solar wind or random interstellar turbulence. The signal was directional, pointing to a moving source that was disturbing the environment as it passed. Along with these pulses, there were changes in magnetic fields, particle density, and background noise. At first, scientists suspected a malfunction caused by the age of the spacecraft, but after double-checking with backup systems, they ruled out internal noise. It was something external. Something was moving through interstellar space, and Voyager was close enough to detect it. The anomaly's movement was not uniform. The pulses varied in frequency and strength, indicating changes in trajectory or speed. Sometimes they became stronger, as if the object was approaching. In space, most movements are chaotic, determined by gravity and random drift. However, this looked calculated. The trajectory looked like the result of movement or control, not chance. Modeling the size and shape of the disturbance showed that it was not a comet, asteroid, rogue planet, pulsar, or black hole radiation. Instead, it looked like a compact but powerful source, possibly an object with high magnetic activity, surrounded by a structure of unknown composition. What really puzzled scientists was how the anomaly interacted with its environment. It didn't just fly through space, it changed it. The environment seemed not just disturbed, but rebuilt. Matter appeared to be deflected or scooped out of its path, creating neat voids rather than random trails. This is unlike any natural object, pointing to either an unknown interstellar phenomenon or an artificial origin. As more data came in, the signal revealed even stranger features. Hidden within the main wave were harmonic layers containing mathematical constants, the golden ratio, sequences resembling prime numbers, and other non-random structures. Nature can create such patterns in isolation, but not usually in combination or in harmony. This pointed to intentional encoding, possibly a byproduct of an engine system or even deliberate communication. One hypothesis suggested that the signal could be an emission from an exotic engine, magnetoplasma, gravitational distortion, or other technology far beyond human capabilities. If true, Voyager had intercepted evidence of interstellar travel centuries or millennia ahead of us. If an object can purposefully move through interstellar space and alter its surroundings, then the galaxy may be much more dynamic than previously thought. The silent void may be an arena for many such travelers, invisible because our instruments rarely detect this type of movement. The discovery of Voyager has reignited philosophical debates. If there is something out there, is it watching us as we watch it? Has it passed through our solar system before? Was the discovery an accident, or a deliberate signal left for us? Researchers found that the pulses of the anomaly were finely synchronized with background cosmic signals that were previously thought to be random. This suggested that the object could be influencing its environment at a distance of light years, possibly through resonance effects, either intentionally or as an unintended side effect of its motion. Its trajectory changed in such a way that it suggested controlled navigation following energy-conserving arcs, very similar to the maneuvers of a spacecraft. This discovery highlighted the importance of long-term missions. Without Voyager, this event would have gone unnoticed. Scientists began to advocate for the creation of probes specifically designed to detect distortions in the environment, to feel space, rather than simply observe it. Some suggested that advanced cloaking or matter displacement technology might be involved, and that the detection was the result of a leak from an otherwise invisible object, similar to how stealth aircraft can sometimes be detected. Physicists have returned to fringe concepts such as the Alcubierre warp drive, the Casimir effect engine, or zero-point energy manipulation. These ideas involve altering space-time itself, which could explain the local disturbances recorded by Voyager. If such an engine exists, it would create measurable gravitational and electromagnetic side effects, exactly the kind of anomalies detected by Voyager. Patterns in the archive data suggest that the anomaly may be moving along a predictable route, a gravitational highway used by interstellar travelers to increase efficiency. If so, Voyager's location may have crossed a busy space route. This opened up the possibility of placing future observation platforms along these corridors to detect more such movements. The discovery of the anomaly changed the discussion at space agencies. Funding for deep space missions was increased, and discussions began on how to respond to potential extraterrestrial technology, even if it was not actively attempting to communicate. Some warned of the risks of revealing our presence, noting that the Voyager Golden Record had already revealed our location and biology. Others saw it as an inevitable step toward interstellar awareness. Signal modulation involved recursive encoding, patterns repeated at intervals, possibly transmitting information spatially rather than verbally. The movement itself could be a language, like the trajectory of a spacecraft acting as handwriting in the stars. This concept led to a new field of research, transient spatial harmonics, which studies how motion and field distortions can encode meaning. The Voyager data became a foundational example for this research. This discovery shifted the search for life from waiting for radio beacons to considering the possibility of silent travelers who do not seek communication but leave traces behind. It reawakened the public's imagination. Artists, musicians, and writers drew inspiration from the image of a lone probe discovering a passing cosmic traveler. The Fermi paradox, "Where is everyone?" was reframed. Perhaps they had been here all along, just moving silently. Theories ranged from ancient alien machines still roaming the galaxy to automatic probes from extinct civilizations and technologies from our own future that had fallen into a time loop. Some suggested that they could be debris from a long-ago event, still carrying remnants of engines that interacted with their environment in unusual ways. Voyager 2 and other probes were redirected to search for similar disturbances. Although none of them were in the direct path of the anomaly, scientists hoped that indirect resonance would still be detected, confirming the existence of this phenomenon. This movement was no longer considered a curiosity, but became a priority for the mission. The anomaly's impact on the environment forced scientists to rethink the concept of motion in interstellar space. Motion could mean not just a change in position, but a change in fields and energies in space, creating shadows in plasma and magnetism. These distortions sometimes resonated like a tuning fork, suggesting not only movement, but also interaction with the environment at a fundamental level. This could be a new form of communication, invisible to most of our instruments. One of the striking discoveries was that the signal repeated with different amplitudes and a slight delay, a redundancy method often used in engineering communication systems to prevent data loss. This reinforced the artificial source theory. Models proposed possible structures capable of generating such effects: a rotating ring-shaped vessel using magnetohydrodynamic forces, a gravitational bubble that warps the space around it and reduces drag. Some data indicate that the anomaly's activity intensified during the Voyager scan. This raised the question of whether the anomaly was aware of Voyager's presence. Although this is not proof, it has led to caution in transmitting messages into space. SETI projects have begun to rethink whether humanity should remain loud in space. If advanced civilizations are being quiet, perhaps they have good reason. At NASA's Jet Propulsion Laboratory, Voyager's faint signals are still treated with reverence. Each data packet is more than 22 hours old by the time it arrives, a delayed whisper from the edge of the known universe. Models suggest that in the coming years, the anomaly will pass through a denser gas cloud, which could lead to new signals. Some have suggested launching a fast probe to intercept or observe it from a different angle, even if catching up with it is unlikely. The most profound change may be the realization that the galaxy may be full of such movements, deliberate, silent, and previously invisible. Perhaps we mistakenly took silence for emptiness. Voyager's discovery does not confirm contact, but it suggests that we were looking with the wrong expectations. The movement itself may be a message. Voyager's longevity and flight range made this possible. A probe from the analog era captured something that modern technology could not have anticipated. The anomaly may be the first note in a great cosmic symphony that humanity is just beginning to hear. This discovery forces us to look at the galaxy differently, not as a static map of stars and emptiness, but as a living space where unknown actors move, form, and perhaps communicate through the very medium of space. For now, Voyager continues on its journey, carrying its golden record and our curiosity into the darkness. Somewhere ahead, something is still moving. And thanks to one persistent spacecraft, we now know that we are not the only travelers in the universe.